Hello, in this video, we will show how to use a pre-trained neural network called ResNet, so R-E-S-N-E-T, for image classification in PyTorch. So we know there are many pre-trained very large network based on millions or tens of millions of image data that we can use. Just download the pre-trained network with its parameters. So it's much easier than to set up our own model to train classification. Because such kind of large models, for example, this is ResNet 50 with 50 layers and trained on millions of data. So this is a very powerful model for classification. If we look at this model structure, so this is incoming with the image. Then after some procession, then the stage 1 is a convolutional and with batch normalization. So second is also convolutional and so on. Then in the end is average pooling. Then with a full connected layer with 1000 scores, which can be calculated as 1000 probability, can rank from the highest to the lowest. And actually, such kind of model, ResNet, are used in classification task competition. And this competition will produce the first or the highest 5 probabilities with the corresponding their class. And if the predicted label for a new image is located in with these 5 labels, then it is correct. Otherwise, it's not correct. So it is very powerful because the labels are the 1000 labels. So we will use this model for a new image with a dog. Actually, the real label is a dog, and we will see if it is possible to get the dog label within the first or the highest 5 labels predicted. And for the convolutional neural networks, the most important layers are the convolutional layer and pooling layer and a full connected layer. So the image coming in, and because there are convolutional fields, for example, image size is 256 times 256. But the field size is like a small square with 3 by 3, so very small. But this can move along the image. So we get the new data from this field. But of course, we can use different fields with different parameters. So for each convolutional, we can get many filters. And the next block, we can also use convolutional. So along the way, the image size in the convolutional layer will be smaller and smaller because the edge of the image will be wasted usually in the convolutional operation. So the image size in each field will be smaller and smaller, but we can use multiple fields and more fields along the way. So in the end, we can use all such kind of information in the field for all the fields and all the layer, all the image in the field. We can use pooling. And of course, pooling can also be used within this block. But pooling has no parameter, just to get the max or average value from some area of the field, of the image point. So after pooling, we can use flattening. Flattening means for all the multi-dimensional arrays, we can get to the one-dimensional array in only one vector, one list-like array. Then from this one-dimensional array, we can get a full connected layer to calculate probability. So this is the main architecture of this network. So next we will use such kind of ResNet to train a new, not train, to predict the label of a new image of dog. We will go to Python source file, and you can download this file. If you visit this website, then there's a menu called download. You can find the contents for the Python machine learning. So we use this file. Then we open this file in the Python IDE. First, we set the working directory and import modules from Torch Vision. So Torch Vision is for computer vision in PyTorch. But you have to install PyTorch first. You have to install PyTorch. So import it, and we show all the modules in Torch Vision, the many modules. You can see the module has capitalized name and lowercase name. So capitalized name is the main module, and the lowercase is the sub-modules. Because the module can be, for example, ResNet can have 100 layers, 101 layers, and 50 layers. So there are several versions. Of course, for example, here we can choose one module called AlexNet. This is also for the computer vision. Then in our example, we use ResNet. So modules ResNet 101 layer pre-trained true. So we can just load this module and show ResNet. So this is the structure, very long structure, similar as in the image we show in the PowerPoint. That's like this ReLU is for the activation. So each layer, each bottle layer will have ReLU. So we also import a transform module because the new image will be processed to adapt the size for the module's incoming image. Sorry. So for example, we resize to 256, and use a center crop to 224. Then we transform to a tensor. Tensor is same name like array, but in neural network called tensor. Then we normalize. This is for 3 dimension because the first dimension is the color. The second dimension is the height of the image, and the third is the width of the image. So we next will use a pillows model image function to load our new image, and this image, this dog, we will use. Then we can show, for example, but this is not perfect, very small. Sorry, but not important. We just use the training process. So next we use the function preprocession for this image, and output is image T. Then we use an unsqueeze function. Next we import a torch, and we then transform the shape of this data using unsqueeze. We add a new dimension. This is for the batch. Although this is only one image, but there must be a dimension for for the batch. So now we can show, for example, shape is 1, 3, 224, 224, which means here is one image and 3 color channel and 224 for the height and the same for the width. So this is a 4-dimensional data. So next we use ResNet evaluate function, which means the model's parameter will be loaded. Then it's quite simple. We just use ResNet for this batch data for this one image. Then model will be run one time from the incoming to the output. So this evaluate function, this model will run from input image to output. So the output is the score for 1000 value. Then we will open a text file which will contain 1000 text labels for the text. Then we will use the maximum out for the max score. We will see what's the index number. Then is a tensor, number 207. Then we will calculate the out score as the probability. Then we will get this index first. Actually, this is a 207, and with the probability for this index from this 1000 probability. So you can see this label predicted is called golden retriever. Actually, this is a dog series, and the probability is 96.29. So very confident to predict this image as a dog, this kind of dog. And next we can show the highest 5 labels predicted for this image. So this is the highest 5. Actually, the first one represents 96%. And next, for example, is the Labrador Retriever and Cocker Spaniel and Redbone. These 4 are all dogs, and the 5th is not dog. So the model is quite successful because the first is correct and has 96% of the confidence. Thanks for watching.